All right, 3.2. So we're going to talk about a little bit on free energy. And you don't need to know how to calculate free energy for the AP exam. Woo, one less calculation, right? Um, but you need to understand the different parts of this equation and how it interacts with our unit that we're currently on. And so the laws of thermodynamics kind of talk about energy and the movement of energy. And so we kind of have to use free energy to determine whether reactions would even occur or not. The chance of those two molecules being near each other at one point to allow that reaction to even occur, even if there's enough of it, which will then kind of lead us into whether enzymes will do work or their job. And so G, or the change, remember the triangle just means the change, the final minus initial. And so G stands for the change in free energy. H is referring to the change in total energy or heat. T is absolute temperature in kelvins. And then S is the change in entropy or disorder within the universe. And so free energy changes the reactions, or tells us whether to determine if our reaction can occur spontaneously or not spontaneous. And so these changes of free energy are based off of whether reactions are exergonic or endergonic. Endergonic reactions are reactions that absorb heat, like photosynthesis. They take in energy. And so G in endergonic reactions, free energy, is going to be greater than 0. Okay, this reaction does not occur spontaneous. It needs to absorb free energy in order to occur. Okay. Just means that our activation energy between our reactants to products is incredibly high. And so cells have a constant flow of materials coming in and out of that membrane, right? We talked about that in our last unit, but they're not at equilibrium. And they do 3 types of work: mechanical, transport, and chemical. We've talked about transport this last unit, right? The movement of substances against gradients, okay, across membranes. We kind of talked a little bit maybe in cytoskeleton, like the different parts of the cell structure, about mechanical, how cilia moves. We will talk about the movement of chromosomes when we get to heredity, and then contraction of muscle cells. Okay, that'll be, I believe, in this unit or the next. And then we're going to talk about the chemical ones right now, the synthesis of molecules. Remember, or we talked about chemical being in that first unit when we built macromolecules using dehydration synthesis, and we broke down those molecules from hydrolysis.